Hey everyone, in this video we're going to be looking at Chapter 5 of Pragmatic Programmer, which is called Bend or Break. If you can imagine it, we are at the halfway point of the book, and I hope you've been having as much fun hearing my thoughts as I've had sharing them. The script writing process takes a long time, but it helps me organize my thoughts, and if I may say, I think the content quality is higher than it was when I was first making chapter summaries and improvising as I recorded. But I digress. So the chapter starts out with this adage that life doesn't stand still. And since it doesn't stand still, we always have to be adaptable to what happens next. There are a few ways that we can apply that sentiment to programming, such as reversibility and decoupling. The first section is about decoupling and why it's important. The opposite of decoupling, as you can imagine, is coupling, quote unquote, and basically means that you have a lot of code that is dependent on other code, maybe multiple functions that call each other, and so on. On the surface, it seems fine to call functions anywhere they're needed, but that makes them harder to change in the future because the more places that they are called, the more vectors for entropy arise, since they'll all likely be affected by any changes that you make. This leads to people being scared to make changes since they don't know what unintended consequences will arise from that. Another place where coupling is problematic is in cases of object properties, and especially if you do property drilling, which is where you call nested properties on an object, or maybe nested properties isn't the right way to talk about it, but the concept is more like, you'd say like car.wheel.spoke.material.color. If anything changes in those list of properties and you don't update that reference in the code, if the wheels are replaced by spokeless wheels, all of a sudden your reference to spokes are not going to work, and that'll cause an error to occur. This is an issue since there isn't a guarantee that a data model will stay consistent over the course of time, and thus if it changes but the places where nested attributes aren't called isn't updated at the same time, that will cause errors to arise, which might result in a crash unless the code is written in such a way that the attributes are nullable. So that's safe navigation is what that's called. The authors offer some tips to make sure that your code is as minimally coupled as possible. So the next section is called Juggling the Real World and starts with a quote from President Kennedy, which says, "Things don't just happen, they are made to happen." Things don't just happen, they are made to happen. So this section is about things happening in our code and how our programs reflect what happens in the real world in a way that is well organized and which will eventually be intelligible to others. We'll start by establishing the concept of an event, quote unquote, which basically means what it sounds like, something that happens. This could be things like a button being clicked, an email being sent, a chat message being sent, or an order being placed. There are 4 different methods that are suggested for handling events, and we'll cover each of them here. The first is called finite state machines. The second is called the observer pattern. The third is called publish/subscribe or pub/sub, and the last is called reactive programming. They're all approximately related and kind of similar, so it's worth noting the differences explicitly to not get them confused. State machines are the easiest to understand. Basically, it's a preset specification of how to handle events, and usually a sequence of events. For example, if an order gets placed on a website, the order goes from one state to another, from not checked out to checked out. When it's not checked out, there is some behavior that it should have and that it shouldn't have when it is checked out, and vice versa. There should be some behavior available to checked out orders that is not available to not checked out orders. From there, the order can advance through further states such as shipped, canceled, delivered, returned, and so on. The world itself is very stateful, and that's what makes state machines so easy to conceptualize. By contrast, the others are somewhat less so. The observer pattern basically organizes code via callbacks, which are registered and then replayed when called upon. This pattern, however, suffers from issues of overly coupling code, and thus has largely been replaced by the publish/subscribe method, also known as pub/sub. An example of pub/sub is email inboxes that automatically load in new emails when they arrive, or text message apps. For an inbox, the browser opens a channel to the email provider's servers and listens, or subscribes, for new events. When the email provider receives an email, it publishes it, and the subscriber receives it through the channel, thus allowing your new emails to show up in real time. Finally, reactive programming is a derivative of pub/sub, where data and events are tied together in such a way that a change in one piece of data results in changes elsewhere. Behaviorally, you can think of it like a two-way pub/sub rather than just having one publisher and one subscriber. Next, we'll talk about a section called inheritance tax. In object-oriented programming, we tend to make base classes of objects and then inherit behavior down through children classes. The problem with inheritance is once you're creating objects that are several descendants from the base class, there are a lot of things that you'll be inheriting which you might not need, thus causing the code to be unnecessarily resource intensive to run. It also makes the code much more coupled, as changes in classes closer to the base have consequences on the behavior further down the inheritance tree. Although the authors make correct points across the board about inheritance, I find that the ease of use and intuitiveness of inheritance's use can make that strategy for implementation worth it despite the drawbacks, and that the drawbacks can be mitigated by not using inheritance with too many layers or too many layers of classes removed from the base. With that being said, the authors suggest using mixins to share behavior, since those can be created with only the functions needed, and thus without having to take baggage from a parent class that might cause unintended consequences. The last section is called configuration, and it talks about the importance of having your application be externally configurable. This could entail things like having environment variables, API keys, and feature flags or dynamic values taken care of in a separate repo than the main app. Doing this gives you the flexibility to change the site without having to redeploy. So that's all for this one. I don't make any money off of these videos, at least at this point in time, but rather for the sake of my own learning and to share that experience with you. So if you found this video and this series helpful and thought-provoking, I'd appreciate a like, subscribe, and comment. I love hearing from you, and we'll see you all in the next one.